give answers to the nearest hundredth, so it kind of tells you this is a calculator question. I see a cos squared and a cos. So this is a quadratic equation. Quadratic equations always set one side equal to 0, so I'm going to move the negative 3 cos squared x and the plus 1 over to the other side. It doesn't matter which side you make 0, however, when you have a quadratic equation, life is easier if whatever your squared thing is positive. So I could have moved everything to the right side, but then my 3 cos squared x would still be negative, and that's just going to make things a little bit harder if I try to factor. Okay. You have two choices here, right? You could either factor or use the quadratic formula. I like trying to factor first, because if you can factor, it is faster. Okay? The problem with factoring first is if it doesn't factor, like this one, no matter what you try, doesn't work, then you have to use the quadratic formula. Sometimes there's ones that we can factor, but we make mental math mistakes along the way and nothing works. The quadratic formula will still always work, so it's not bad. Even if it's factorable and that's the shortest way, if you use the quadratic formula, that's not bad. So again, here's our quadratic formula. I'll write it out in green. I won't write the 4ax squared plus bx plus c part. Again, on your formula sheet, it's x equals because it's 4x squared. But what do we have squared? We have cos squared. So we will write cos x equals negative 1 plus or minus 1 minus 4a is 3, c is negative 1 over 2 times 3. Simplifying this, negative 1 plus or minus the square root of 13 over 6, which we can split up, 1 with the plus sign, 1 with the minus sign. And I think it's pretty obvious that those are not on our pie plate. So we're going to have to use our calculator. And again, with the ones with the quadratic formula, I find it useful to actually type that in to begin with. So I'm going to have negative 1 plus the square root of 13 over 6. Get that decimal and do it again with the subtract sign. So I get 0.434 for this one. And on the other one, I have negative 0.767. And it would round up to an 8, but because I put the dot, dot, dot there, I'm just saying it's the right decimal places and they keep on going. Now we're going to have to find a reference angle. Because they're using x in this question, we'll have x with a little r for a reference angle. So I go to my calculator, I'm going to go second cos inverse, and this is the first one that I'm doing. Reference angle of 64.26. Is this question in degrees?
No.
Oh. So I have to go back to my calculator, hit my mode button, change it back to radians. But I don't have to retype everything because I can just go and highlight this again. And now 1.121 That's my reference angle. And solving between 0 and 2 pi, cos is positive. It'll be in quadrant 1. Oh, what does it want me to round to? Nearest 100. So then I'd be good there, 1.12. And then in quadrant 4, because cos is also positive in quadrant 4, I would go 2 pi minus, and I can go second answer, 5.16. On the other one, I have a negative, so when I do cos inverse to find my reference angle, I have to do cos inverse of the positive value. I'm going to go back up and highlight it. Because when I highlight it, I don't lose any decimal places, but you see that it has the negative. You have two options here. You can either use the arrow key and go all the way over to that negative and delete it, but I find it's quicker just to multiply by -1. That makes it positive. And then 0.6957. Now here, cos is negative in quadrant 2 and quadrant 3. So I'm going to have to use this more than once. I really like to use my store button on my calculator and store that reference angle as x. That way when I go to quadrant 2, which is pi minus my reference angle, and quadrant 3, which is pi plus my reference angle, I can do it that much quicker. So I get 2.45 and 3.84. Awesome. Now, that was a lot of work. And I'm feeling like sometimes you get to this point, you've done a lot of work, you just want to go on to the next question. But always read the question, because what did I do? I solved between 0 and 2 pi. This question better not say it does, oh no. Okay, we'll make a note, right? These answers, those are answers between 0 and 2 pi. And it's a good strategy to solve between 0 and 2 pi because you sort of get into a rhythm, right? You know what you need to do. It's a nice systematic thing, but then you read the question and somebody's already shaking their head that I'm not going to be happy. Oh, look at that. Negative pi to pi. So I'm going to draw a picture of that. Negative pi to pi means in the positive one, 0 to pi. In the negative ones, and when we solved between 0 and 2 pi, we did all positive ones. So now I have to rewrite them. Which ones can I keep? I can keep quadrant 1, and I can keep quadrant 2. My quadrant 1 answer was 1.12. I can keep that one. My quadrant 2 answer, maybe I'll even, right? There's positive quadrant 1 and quadrant 4, quadrant 2 and quadrant 3. So I can keep the quadrant 2, 2.45. But now the quadrant 3 one, I have to figure out what angle this is with this reference angle. Now there's a couple, there's a little bit of a shortcut in this one. Because does it make sense that if you know the quadrant 2 one, I'll show it in green here. If I know the quadrant 2 one with this reference angle is 2.45. And if I have the same reference angle in quadrant 3, but now I'm going negative, can you see that that's identical as far as distance goes? So I can write that one as negative 2.45. And same thing in quadrant 1. If I went to quadrant 4, it's just going to be the reference angle negative, so the quadrant 4 one will be negative 1.12. That is our final answer.
might not be bad to put a line through the ones that we had to take out, because they didn't fit the domain the question was asking. Does this one ask us to also do the general solution?
Yes.
Again, if you look in your textbook answer for the general solution, they would probably use the ones that we have in the box here and add 2k pi to all of those. For me personally, I like to use, I'm going to scroll up a little bit, I like to use the 1.12, the 2.45, the 3.84. I like to use just the positive ones. So another benefit of solving between 0 and 2 pi. We add 2k pi to each of them. Whew. Do you like these quadratic formula ones? No. They're not, it's like, it's the same thing, but just having all of those decimal places and just feels more onerous, doesn't it? Like easier when the numbers are nicer. Questions for practice on this one are 12, 13, and 14.